Hello everyone and welcome to this Jumpstart. We will talk during this MVA course about BabylonJS and WebGL. We will talk about 3D, gaming and a lot of really fantastic stuff we can do on the browser. I'm here with my friend David. My name is David Ketu. I'm working for Microsoft. David is also working for Microsoft. And one thing we wanted to let you know is that you don't have to fix your speakers. The weird sound that you are hearing is the French accent.
A beautiful French
accent. Absolutely. Someone told us that this is the sexiest accent in the world, so that's why we decided to keep it. So, as a point here, my name is David Ketu. My Twitter is @DeltaCoach, and if you want to reach me, feel free to ping me on Twitter.
And my name is David, so we are the Davids, and you can reach me on Twitter on DAVROUS. And I am French also, and I really love 3D, and we're going to try to share our passion about 3D during these 8 hours.
Yeah, so be prepared to a lot of content. Okay, so just setting some expectation. If you want to follow this course, you have to be a JavaScript developer. Even a beginner is okay. Or if you want to become a game developer, we think that this course is also for you. The only prerequisite you may have is having Visual Studio 2013. The Web Express edition is okay. This is a free version. You can use it without any problem. This is an MVA course, so please join the MVA community. You have a lot of information about this community in this specific slide. You can earn points, and you can enter the WebGL3D1 if you want to gain more points. Just a big picture before starting. We will talk about 3D. This is the point. We will discuss about 3D during 2 days. So during the first day, we will talk mainly about the basis, starting to understand what WebGL is, and then we will start introducing the engine we will use right after, BabylonJS. The very first chapter, named Understanding the Basis, will be driven by David, the other David, and it's mainly about how things are working under the hood. So it's not about 3D accelerated and GPU and things like that. It's more about understanding how the clock works, how everything is working. Then we will talk about WebGL itself, and obviously we will start then using BabylonJS, and you will understand why you will love BabylonJS. Just before starting, the agenda for this specific chapter will be the following one. To understand 3D Basic, David, the best idea we thought was to understanding by writing everything. I mean, not using the GPU, but using the CPU. And then you will explain us how to use the transformation engine, what triangles are, and the vocabulary that we will have to use. And then I will just conclude with a really small presentation on what moved from CPU to GPU. Okay? And we love to do that. Just before starting effectively, we will like to do a simple teaser with you guys. And the very first one is to demonstrate you some kind of demonstration we will create during this course. So for instance, the very first demo we have here is on BabylonJS website itself. And we will learn during this long course how you can create this kind of experience. This wonderful V6 engine, I call it V8 on the website, but I'm not a mechanical guy. This wonderful V6 engine was created by Michel Rousseau from France, our best friend, who is a 3D artist, and I send him a big hello, a big up. And it was done with 3ds Max, and we will talk about that. Some other information, David.
And also that the 3D engine we're going to use also work on the mobile. So you can see my Windows Phone up there that is WebGL compatible. And on my screen, you can see that I can move inside the scene, and I can even switch to use some virtual joystick camera. So if I'm using with my 2 fingers, I can move inside the scenes. So we'll see how to create that together in a very simple way in one of the chapters when we learn how to use the inputs, the various inputs. And also, So this is running perfectly fine on the mobile. And you will also see that we have a physics engine embedded in our engine. So if I'm running this beautiful scene that has been made also by Michel, if I'm pressing the S key, and I have a lot of balls falling from the top
From
floor,
nowhere.
from nowhere, yes, and boxes. And you can see I can even shoot some balls, and everything is being enabled, the physics engine and the collider of the scene, and you will learn what a collider is during this course also. So a lot of fun stuff you will learn during these 2 days, and you will see that even at the end of these days, currently, you will be able to do some great stuff.
Thank you, David. So let's start.
Let's start, yes. So let's go back to the slides. And let's start by understanding the 3D basics via what we call a software engine. So a software engine is using the CPU, basically. So we'll go back in the old good days when we didn't have any GPU. And the idea is really to understand how everything is working. So to set up the vocabulary that you will find back in a real 3D accelerator engine using WebGL and Babylon or any other 3D engine.
Yeah, because the story is here that CPU or GPU use the same techniques, right?
Yep.
But it's just accelerated a lot by GPUs.
As we've got a lot of cores on the GPU that are very dedicated to specific tasks, you have some tremendous performance differences between the CPU and the GPU.
But the algorithms are the same.
The algorithms are the same. The idea is to let you understanding how to build that. So we're going to use HTML5 and the 2D canvas, which is not the WebGL one, and we will move to the WebGL version in the second chapter. So everything starts by triangle. So we call it wireframing. So you can see that this is a monkey head we will see in via a tool named Blender. And the first step is to draw some triangle to build the 3D magic. Then the second step is to put some pixel inside it. It's called rasterization, and you've got to find an algorithm to fill every pixel inside every triangle. And the second step is to add some shadows and colors. So you can see I don't have any specific shadows. So the idea is to add some shadows using some specific algorithms.
Yeah. So we fill the volume.
You can fill the volume now thanks to the shadows and a specific light that we don't really see, but there is a light already. And the simplest algorithm is a flat shading one. And then there is a second algorithm that maybe most of you have already heard of. It's a guru shading. So it's a French guy.
Yeah.
Sorry for
Once
that.
again.
Once again, we are everywhere. And then that's try to remove the triangle. You can see that it's kind of really gradient.
Yeah, by smoothing the color.
Smoothing the color, you're right. And the final steps is to add a texture to make really some life to the 3D objects. So it's named texture mapping. And then you need really some 3D artists to help you doing that.
And we have a monkey with a mustache.
Yes.
Interesting.
Of course. So now let's have a look to this specific engine, if you want me to. So I've got here the shortcut. So let's run that in IE. And you will see the various steps we're going to see together. And I'd like to first show you by pressing the Ctrl-Shift-U. You've got the performance. So we are at the best frame rate possible, which is 60 frames per second. And you're going to see that even with this simple geometry, we're going to lose some frame rates. So let's go to the next version, which is the rasterization.
And we can feel that the frame rate is not
already,
at 60.
Yes, already falling. Then I'm going to add some shadows. Then now you can feel the volume. To have a better algorithm using the guru, then you see that I've lost again some frame rates. And finally, using the texture. And if you go over there, you can see that I've got only 25 frames per second. So you can say that we are not ready to build the New York City with this engine, which is pretty sure. So that's why we will need the GPU to do that. But the good point is you're going to learn everything. You can build any 3D engine like that in any languages. So this is JavaScript and HTML5, but you could build it with C#, TypeScript, Java, what you like. And you're going now to see how to build that together.
So everything is done by the CPU on this specific soft engine, and everything is done by your own code. There is no hardware help at any moment.
No magic, so everything done on a very simple piece of code. So the first step is to understand the transformation pipeline. So the problem you probably think that when you're building some 3D is you've got to be a 3D guru and in maths and know about metrics. So we won't focus on metrics problem. We're going to use a library dedicated for that. That's going to be a black box. So I'm going to ask to this black box, please move the 3D object on this specific area, please do this rotation on the y-axis, for instance, and the magic will occur. So I won't explain how metrics work. I know that you're a guru in metrics, but we won't see together the metrics. So let's put some vocabulary together. So most of the time in the 3D world, people think that some of us are some gurus because we are using some weird sentences and weird vocabulary. So let's unmystify that. So the first thing is a 3D point. A 3D point in the 3D world is named a vertex. So maybe you already heard about what a vertex is, but a vertex is simply a 3D point in the world.
So 3 coordinates, x, y, z.
Yes, this is a vertex. If you've got several of them, it will be some vertices. And most of the time we're using what we're naming a vector 3, so using the x, y, z coordinates to set a position in the 3D world or to set a direction. We are using the same type, which is sometimes a bit confusing for beginners, but the idea is you can set point in the 3D world or you can set a direction using the same type.
Yeah.
What we calling also the triangle, most of the time is named also a face or a polygon. So I guess when you were young, you were hearing this specific GPU is able to handle this amount of polygon per second, of triangle, of face per second. This is the very same thing. And finally, a mesh is a 3D object. So what we've seen with the Susan head, which is a 3D object, is simply a mesh. So thanks to that, you have all the needed vocabulary to start. So we are working inside the Euclidean space using some Cartesian coordinates, so x, y, z again. The first thing you need to understand that when you start building a 3D world, you start by concentrating yourself on the object itself using a local model. So the first thing, for instance, you did a cube, you will be centered on the center of the cube. Then you're going to create the different vertices using some specific coordinates. So you can see you've got 8 of them for a cube, of course. So we've got -1, -1, 1, etc. So you start by doing that, building the object on its own model. Then you're going to move it in the 3D world, so which is named the world space. So for that, you need some metric computation again that will be offered by some 3D math library that you will be using probably. And then finally, once you've set all your objects in the 3D space, so let's imagine this room. We start building this room. So we've got the beautiful TV screen. We've got you. We've got some screens. So we're setting the different 3D objects in our scene. And finally, we got to mimic the current camera looking at us. So the camera is not viewing all the room, it's only viewing part of the room. So we're going to set up a specific matrix computation for that that's going to mimic that. This is the point of view of the camera. And finally, probably most of you are not using a 3D screen at all.
Not yet.
You're using a 2D screen. So the final step, when we've set up everything, the camera, the various objects in the 3D world, is to project that on the 2D screen. And this is named the screen space, and we're using projection mechanism for that.
So we have 3 matrices, in fact. The first one is the world matrix, moving from the object where is it at 0 to somewhere in the space.
Yep.
Then defining the point of view of the camera, which is the second matrix. And the third one is projection of the 3D space to 2D space.
You're perfectly right.
Thank you. I'm happy.
So let's start by viewing 8 vertices. So for that, I've got my first example. So we're going to open that. You will have them available for download if you want to, and we've set up a complete tutorial to let you learn how to do that. So what I'm going to open is to open the soft engine.
So basically here is just one JavaScript file.
It's one JavaScript file. So we're using Sublime Text. You can use Visual Studio if you want. You can using every kind of tool that help you to build some.
Yeah, this is the magic of the web.
This is web. And the first, you've got to define several objects. So the first one is a mesh. So we were talking about that. The mesh is a 3D object. So what do you have for the mesh? You've got a name to set. You've got several vertices, which is an array. You've got the rotation of the mesh and the position. And you can see that I'm already using our own library, but you can use every kind of library that's going to provide you some matrix support.
Because vector 3 here is just an array of three numbers.
Sure. And then maybe this object got also some specific function to help you doing some specific thing,
like zero here.
Like 0, but you can have created 0,000,
yeah, absolutely.
And you won't have any problem. Then you need to create a camera. A camera is simply a position, and it's going to look at something specific using the target. Then you need to create a device. The device object is the most important one. It's going to act as a layer between your code and the final screen. So the idea is to create the device using a canvas object, which will be a 2D canvas, and we will see that in the future we are going to use the WebGL, the 3D version. Then you're going to set some various things like the width of the canvas, the height, and then you need several things. There's several moments in the 3D creation. The first thing is to present the pixel, and then to clear it. So every frame, we're going to clear the screen and recreate it from scratch. So this is really important to understand, and we are going to use some new stuff like request animation from HTML5, and then you're going to ask to the code, flush all the data on the screen, all the points, all the triangle in the near future, and then clear it.
So you mean 60 frame means 60 times per second you do that?
Every 16 milliseconds, you've got to be ready to redraw everything. Okay, so once you've done that, you need to put pixels. So that will be the first thing. So as we're using some canvas things, so to put a pixel, you've got 4 information. The first one is a red, green, and blue, and the final one is the alpha. So that's why you need to move inside the buffer using this specific code. And finally, what you need to do is to project everything on screen. So what we're calling that, to remind you that we are not living using 3D screen at home, so you need to project on 2D. And for that, we're using some specific matrix computation offered by this library. And we're moving then from the 3D world to the 2D world, okay? The final part is how to render everything. So you need to create a specific metrics for the camera, so the position and various things like in real world when you're using a camera like this one, it's got some kind of possibility to view some big things or small things, depending on the physical property of the camera. So you're going to mimic that. So this is the field of view you're going to set. And once you've done that, you're going to go through all meshes of your scene, so all 3D objects of your scene. You're going to have access to it. You've got to do some various computation. And at the end, you see that the transformation matrix is at 1. So you need to come from the local space to the world matrix, and finally to use the projection matrix to put onto the 2D screen.
So we can see world matrix multiplied by view matrix multiplied by projection matrix. So it's only one matrix at the end, which is the aggregate of all the matrix we need.
Yeah. And finally, using that, you can project everything on screen.
It's incredible. I love mathematics.
So probably that you're going to say that this is really complex. So, but it's really interesting to understand it's working. You don't need to be some math gurus, because if you're using a library like the one we are using in the tutorial, you can unfairly understood that you just ask to the library, please move this object to that, then rotate it. And maybe you won't understand the matrix things, but at least you will understand how everything is moving from the 3D version to the 2D version. So finally, what you need to do is to instantiate this engine. So here it is. So we got the request animation frame coming from HTML5 with a simple fallback if you don't have it. And then what we're going to do is to create 8 points that we've seen in the schema of the slides. So you're going to create the 8 points. You're going to set the camera position and target. And then finally, you're going to have a drawing loop that's going to try to display everything every 60 frames per second. So as I was saying, the first things you need to do is to clear. Then you ask to your mesh to change their state during each frame. You're going to render them. You're going to present them on screen. And then you're going to restart everything from scratch. OK? So let's see the output. And here it is.
Wow.
This is beautiful, isn't it?
Yeah, it is. So we have 8 3D world. 8 3D points. Yeah.
8 vertices.
Yeah, it's incredible.
So now the next step is to draw some triangles. So let's go back to the slides. So everything is about triangles. So to draw a triangle for a cube, you need to understand several things, obvious things. A cube is made of 8 vertices. We've already seen that. Each face is made of 3 vertices. And a cube is then made of 12 faces.
Yeah.
So what you need to do is to set up some kind of face based on a group of 3 vertices. So once you've got the 8 vertices, you need to group them 3 by 3 to build the face. And once you've done that, you can have a specific algorithm to draw the line between every vertices. So let's see that. Let's start by viewing the first sample. So now when I'm going back to the
render itself.
The render itself, you can see that what I need now is to extract the 3 vertices I need to project them in 2D space and then to draw some line.
Yeah, the difference here is previously we just drawn only
1 point.
1 pixels.
Yeah.
Yeah, and right now we draw a line between pixels.
That's right. And the first algorithm we're using is a very simple one. So, and we're going to see another one just after that. So if I'm running this code, I'm going to show you that I've already built a square. So a square is made of 4 points and 2 faces, okay?
Yep.
And then I've got the 4 vertices defined here. And now if I'm running that, you can see that I've got the square, okay?
Yeah.
Beautiful. And you can see that it's a bit choppy because we're using a very simple algorithm. There's been a lot of researches to end that, so we can go back to this part. So we can change, for instance, rather than using the draw line, we've got another algorithm, which is beeline.
Wow.
For Brethenham.
Yeah. This is the name of the guy who would find this algorithm.
So if we're saving it and pressing and reloading it, I was about to press F5, but just forgot not to shut it down. Now it's a bit better. I don't know if you can see it on your screen with all the compression.
It's
of
less
the video.
choppy.
It's less choppy, trust me. And then the next steps is to add the complete cube. So to have the complete cube, you need to go back to the main part when you're instantiating the engine. So rather than having 8 points, 4 points, I'm going to have 8 points.
Or 8 vertices.
Or 8 vertices and 12 faces.
Absolutely.
Okay, so now I need to uncomment that. I've got all my 8 points.
So you need to add missing faces.
The missing faces, so you can see that this is some group of indices.
The first face is point 0, 1, and 2.
Yes, from this specific array, and then is 1, 2, 3, 1, 3, 6, etc. And finally, if I'm uncommenting correctly.
The interesting thing is that you just have to change the data in input because your code itself just goes through all the faces.
My code doesn't know about which kind of 3D object I'm going to display. It's really agnostic to that.
So if you have enough time, we can create, for instance, the city of New York based on millions of polygon faces and millions of vertices, right?
Yes, yes. So we don't have time to build New York City, but we have time to build a monkey head. So I'm going to show you how to do that. So let's go back to the slide for that. So Of course, what you're currently thinking is, do I have to build every vertices myself and every face myself? Because if for a cube, it's already a bit boring. So what about building the New York City or building some nice scene that we've seen at the beginning of, of the show? So this cool thing is once you know how to load a cube, you know how to load everything.
Absolutely.
So it could sound magic, but it's really the case. So as you don't want to hardcode everything yourself, you're going to use some tools. So the tools are very well known today. So the first one we're going to see together is Blender, which is a free open source 3D modeler. And you probably know also about 3D Studio Max or Maya. That is not free, but very powerful. And so we're going to start by using Blender. So yeah, the idea is you can use the 3D tools, and then you're going to analyze what is being built by the 3D tools and flush that in your own 3D format and reload that in your 3D engine. So we're going to do that. So we're going to output some JSON files and then reload it in our engine.
We will go back to Blender 3ds Max in chapter 5, guys. So next day, but stay tuned.
Stay tuned. So the first thing you need to do is to have Blender, which is already installed here, and you need to also take our exporter, which is a Python script. So you will have it in this MVR course as a download resources, and going on my blog, you will be able to download it. So once you have installed Blender, you need to go to Program File, Blender Foundation, Blender, the version of Blender you've installed, Scripts, and Add-ons.
Pretty deep.
Okay, so once you've done that, you need to copy-paste this file
into this specific folder.
Yes, so let's do that. There's already a version, let's erase it. Okay, once I've done that, now I'm able to run Blender. Oops. And let's start by removing stuff. So let's start by removing the cube, the default cube, delete. And let's add, for instance,
create. No one.
Creates. Let's add a monkey
head.
Okay?
Yeah.
So once you've done that, there's a lot of triangle inside that. What you can do is exporting that using the Babylon, which is not already there. So to have it, you've got to go in User Preferences, Add-ons, search for Babylon, and then enable the checkbox, go back, and then now you will have access to BabylonJS, which is our JSON format, but you could be your own format. So he asked me where I want to save everything, so let's do it here in a very clean way. So chapter 1.babylon and export it. Now if I'm going in the folder, you can see that I've got a Babylon file, which is just some pure JSON. So it's going to, it created for you all the vertices. So let's remember about the cube with all the 8 vertices. So now you've got a lot of them, a lot of faces, and you just need to reload them in the 3D engine. So to do that, let's go back in the chapter 1. Now we need to load using some piece of code. So we have modified the engine for that. So this is a very same code, but now we've got a load JSON file async method. It's going to do an Nixar share request against the web server. So you need a web server. This is the first point. So you cannot load that from the file scheme. And then you need to create them from the JSON. So the idea is simply, I'm going to open the JSON file and take the data I need to create the vertices array, and then to create the faces, and finally to create the mesh and put everything on the right position and put that in my mesh array.
Yeah, it is exactly what you did before by code, but right now it's just reading this information from JSON.
Exactly, exactly. So once I've done that, I simply need to do another thing, is to open that and to call this specific load JSON file async function that's got a callback function over there. So when it's completed, I can take the loaded mesh and run the very same loop. This code hasn't changed at all. So it's going to take the same mesh as previously. So this is the first step where you will probably need some Visual Studio, another tool that's going to help you to create a web server. So we're using Visual Studio Web Express. This is the free version, so I'm going to close that one and to open a new one. So you need to create a new project. So we're going to call it
Chapter 1.
Chapter 1. Okay, it's going to be an empty project. And I've got chapter 1, and what I need now is to drag and drop my files over there. And the final step I need is to configure the web.config.
Yes, I will talk about that later.
So just need to create a MIME type to help him understanding what's going on.
Yeah, because by default, the web server does not know anything about .babylon file, so he doesn't want to serve something. He doesn't want to serve something he doesn't know.
That's why you will need a web server to do that. So once you've done that, I'm going to open that in the browser. And you can see my monkey head is now being loaded and rotating. So this is really the idea. So once you've done that, now we're going to switch quickly to the various other step is to draw inside the triangle using a rasterization algorithm.
So basically something we already did, drawing line, but this time in order to fill triangle.
Yes, and it's a bit more complicated, but everything has been written about that, so you will have the tutorial again to deeply understand what's going on. If you're really interested in building your own 3D engine, which is pretty cool, I think, but if you're not interested in doing that, you will just have the basics to use it in a full 3D engine like BabylonJS.
Obviously, all the samples here will be available as download in this specific course, so you can play with it, and as you said, you can create your own 3D engine and become rich with that.
Let's hope so. Now, let's see how to the various steps. So you need to fill the triangles with lines. So you're going to draw inside a triangle. Then you must pay attention to the Z order, which means that when you will draw a triangle, you don't know maybe by default if this triangle is not in front or back of another one in the future. So you need to know the Z position of this triangle. You need to add lights and shadows. So for that, we need what we're calling normals. And there are three different kind of shading algorithms. So the simplest one is the flat shading. So you've got one normal per face on its centers, like you can see on the schema on the right. And then you've got the Gour shading when you will have three normal per face on each vertex. And then using some interpolation techniques, you will be able to compute the various colors using gradients and making feel that the triangle is a bit disappearing, better smooth.
Yeah, so normals, in other way, is the vector which is perpendicular to the face itself. It's always perpendicular to the face itself.
So you've got two techniques. The first one is to compute it using your code, or to load it from tools like Blender. That's going to patch that in our file format, for instance, and it will save you some time to avoid computing it. So this is what we're going to do in this simple example. So let's go back to the monkey head. And you can see that using Blender, you can see the different normal of the face. So it's going to compute it for you. Then you need to add some lights. And a light is just a point in the 3D world. Once you've got that, you get to compute the angle between the normal and the light. You will have an angle, and this angle will be the amount of light you need to put on the triangle.
And it's pretty obvious, because if the light is just on top of the point itself, then both vectors will be exactly the same, so the angle will be 0. So we can say that we have a lot of light when angle is 0. And in the opposite, when the object is, let's say, perpendicular, then the angle will be p over 2. Then we can say that if p over 2, then no light.
Yes.
So it's just linear between these two values.
Very simple to compute. And finally, you can see that we've got the two techniques. So the first one is the flat shading using some surface normal, and the second one is using the groove shading. And using the groove shading, what you need to do is to have some liner interpolation between the various colors. So let's say that the up vertex is black and the two other ones are white. You can see that there is simple gradients on the face to simulate the lights and the proper shadings. So pretty simple.
Yeah.
So let's view that now directly finalized.
Let's code that.
So the idea is not to review the complete code. As I said, you will have the complete source code to review that. So it's just to show you what's going on using the various techniques. So I'm going to press Ctrl F5. And you can see that this is some funny thing. It looks like you can see through the triangle.
Yeah, sounds like some triangles are missing.
Yes, because maybe this one shouldn't be there. Maybe it should be rather on the back or on the front, I don't know.
So you mean there is no ordering between them?
Yes, I'm drawing everything in the way they are currently defined in the file format, but maybe they are not sorted in the...
Yeah, we need some sort.
You need some sort. To sort them, you need some Z ordering, so Z buffer. And
so you mean we should just draw the faces that are near us?
Yes. For that, you need what we name a depth buffer. So let's reload everything using the other techniques. Again, feel free to have a look to the source code to better understand what's going on. I'm going to reload that.
Oh, this time it's far better.
Yes. Just doing something. You can see that I'm launching AI not in debug mode to have better performance. And are not really good.
Yep.
I can feel the volume. So the only thing I've been doing is to Z sort every faces.
Absolutely.
And today, of course, it's done by the GPU. But at this time, when we were playing Doom games, it was your job to do that.
It was done only by CPU, yeah.
Only by CPU.
And the interesting thing here is that every time you add some options, the CPU will be more overloaded each time, which is...
That's why we are dropping the frame
Absolutely.
rate every time we are adding a new FX. So now let's see how to have some flat shading. So I'm going to close the various Visual Studio project open. Up. And let's go back to the part 6 of my demo. So using flat shadings.
So this time, normal will be computed just once per face.
Yep.
So each face will have one color. This is right?
Yes. If
I
it's
think
loading,
you stopped the...
You've stopped the web server.
Yep.
Okay. So let's reload it. You know what? I'm going to show you how to do that. So property on the web project, going in the web part. I don't want to directly open the page. I just want to start the web server. So I'm pressing Ctrl F5. And now I can copy paste that in the browser. And now you can see we start to have the flat shading.
Yeah, that's pretty interesting. We can feel that the light is over the head because the back part of the monkey itself are black.
Yeah.
And the top part are almost white.
But we can still see the triangle.
Sure.
So this is very simple to compute because you just have to draw using a simple color every face. So the idea is to try to remove these slight bad geometries is to smooth everything using the groove shading.
So, it can be a Minecraft emulator.
Yeah. Now that Minecraft is part from the Microsoft family, yes, you can.
We can stop here.
So let's see how to see the groove shader. So I'm going to close the Visual Studio project again. No, not like that. There it is. Let's open the groove shading. Let's do the same techniques. So properties, go to the web part. Don't open the page right now. Copy pasting that. Control F5.
So this time we will have one normal per vertex, which means that that's just awesome.
Much more beautiful, yeah. And now it's more difficult to see the triangle. You can still see them because the idea to to enhance the quality, there is two ways to enhance the quality. So you need more triangles.
Yeah, obviously.
Obviously, but once you've got more triangle, the performance is going to slow down even much more on the CPU. And the other techniques could be to enhance resolution.
Yeah.
So let me show how we're doing things right now. So we've got here a canvas element, and we're setting a specific resolution.
Oh, okay. Which is not full screen.
Which is not full screen.
Okay.
And the idea is something that's being done in much of the time in games, that you're going to compute the 3D world in a specific resolution, and you're going to upscale it to the final resolution using what we are naming the hardware scaling, meaning that this is the job of the GPU to compute every pixels and to have some kind of anti-aliasing algorithm on top of it. So it's much better for the performance to compute everything on a small square and stretch it.
Yeah, because less pixel, so more time for everything.
Yeah. And the funny thing is that the algorithm to stretch them could be done on the specific hardware. So this is what we're currently doing in a way in our soft engine, meaning that I'm currently computing that on a specific resolution, and I'm asking the canvas to be stretched 100% on the width and height. And this is done by Internet Explorer. That's going to use a GPU for that and to stretch it using hardware scaling. So I can enhance the resolution, for instance, and kind of, for instance, that. And let's hope that my CPU will be okay with that.
We hope so.
And I'm going to reload. And you can see that now it's a bit more smooth.
We barely can see pixels
but
right
the
now.
Performance should be a bit less better. You see? So there's two approaches to do that. So let's go back to the slides.
So next step, textures.
Textures. And everybody wants texture, of course.
No, obviously. I want a mustache on my monkey.
So maybe it will remind you when you were a little child. So at least it reminds me when I was a little child. And I was a Jedi when I was a child.
Really?
And the first thing that you need to understand is you got a texture and you need to map this texture on your mesh. So for that, you need what we name UV maps. We're going to see just after that. But I think that this schema is pretty
that's obvious
that you can see that's what's going on the cube. Obviously, it's a bit more complex on the sphere or monkey head, but this is the idea for a cube. On more complex objects, you need what we are calling unwrapping. So let's take the monkey head. If you're pressing the monkey head on a 2D space, you can have something like that. So now you are able to draw in 2D on the various parts of the head. And the idea then is to obtain something like that in our case. So you don't need to repeat the information. For instance, you just need to draw one eye that's going to be applied on both using different coordinates. Same for the mustache and the teeth. So the idea is to have something very light. And then once you've done that, you need to put this texture on specific coordinate on your mesh. So this is named UV mapping.
Yeah, okay, so it's 2D coordinate on 3D object, on 3D vertices.
Yes. And then maybe you will try to figure yourself, yes, but if the texture itself is not bigger enough to be stretched on a 3D object, so you're going again to use some interpolation of the pixels to, like we've done with the gradient in Guru, to put that on the 3D objects.
We call that texture filtering in order to not see too much pixels when you are dealing with textures.
Yep. So the final project you will have, let's open it.
The final soft engine.
The final soft engine.
Brought to you by David.
It's a bit difficult to go much further than that. So we've got the texture over there.
Yeah.
We've got the Babylon file that's a bit different than the...
Yeah, because you need normals and UV coordinates.
Yes, I need UV. And maybe you know about UV. It's I was asking you when I was learning 3D, people were asking what UV stands for, and you told me it's just before X, Y, Z in the alphabet. So this is the way the 3D guys are thinking. So this is very obvious. Don't try to think that U for ultra something.
No.
It's just U in the alphabet. And once you've done that, you need to take the texture and put that on the 3D meshes. So let's run that. And you
Wow.
see it's very slow in debug mode. So don't do that at home.
We are professional.
Yeah. So what you need to do is to
Same story, start the project.
Start the project here.
But do not launch IE in
Do not
debug.
launch IE. Control F5. And finally, we've got the beautiful monkey head with the texture, lightning, shadows,
Wow.
using only CPU.
Yep, that's pretty interesting, but we are all okay about that. It's not possible to create a game, I mean a modern game with modern 3D graphics like this.
Yes, and we are in JavaScript, which means that even if the JavaScript engine are pretty fast now, when we were using Doom, we were using some C and assembler code, try to really optimize everything. So it's a bit more complex to do it in JavaScript, but hopefully we've got a new gamer that entered the course and the WebGL and the GPU.
Yep.
So maybe you can show something on your desk. Maybe.
Absolutely. The thing is that we learned how to create a 3D engine. This is pretty interesting, and I really love that. And I really urge you to read all the doc, all the samples we built for you, because this is exactly how a 3D engine is working. But we need tools. We need help. We need, in this war against performance, we need more powerful soldiers. That's why we need to move from the CPU, which is extremely powerful but not really dedicated to pixel treatment. And we need to move from this CPU to a really powerful guy, the GPU.
The bad guy.
The bad guy, yeah. The guy who knows how to fight against pixels. Just one thing before we moved to the next chapter, David, is that the rise of the GPU is everywhere. When we look at the history of browser, we can see that the GPU, I mean Microsoft, Mozilla, no, I think it's Mozilla in English, sorry about that.
Google.
We all think about trying to move a lot of things from the GPU to the CPU in order to get better performances. For instance, let's have a look at 2D canvas. You just talk about that you can use hardware scaling in order to change the resolution of your canvas and stretch it to full screen. It's something that it's done by the GPU itself. But if you think also about CSS3 animation and transitions, it's also something that the GPU work for us. We already shipped something interesting with the latest version of IE, which is hardware decoding of JPEG. I mean, JPEG are pixels. And we need to uncompress things like that. So we can use the raw power of the GPU to do that. There are two big points for that. The very first one is that when you do that, the CPU can do something else. So the GPU is working on decoding JPEG, then the CPU can work on loading the following page and things like that. But it's also extremely interesting from the point of view of the battery itself, because the GPU is a guy who knows how to do that very efficiently. So it can do that in less time than the CPU itself. So we have to use less battery for the same job.
Okay.
That's really interesting. And obviously, decoding video was also something that browsers moved from CPU to GPU. H264, for instance, decoding is done, I think, everything is done by the GPU itself. The latest move we can do is about 3D. Right now, doing CPU-based 3D engine is fun, but it's not really a good way to create 3D games. That's why we will talk about how to use the raw power of your GPU, not for decoding JPEG, not for decoding video, not for CSS3 transition, but for creating 3D. So we will have a break, just 10 minutes, guys, and we will come back to more 3D world. Thank you.
See you soon.